All right, thank you so much for joining us today. So we've looked at, finding derivative using the limit definition. But you know that some functions are very complicated for us to, go through the limit definition, do cancellation and get the right results. So we need to look at now the properties or the rules that we can use to differentiate the function direct, right? Now I've grouped this one into two, and I named them general rule, that is the formulas, and then rules for, so general rule, that's the formulas that we need to know. So when you talk about formula, okay, this is the formula, right? And then rules for differentiating individual functions. So that is one thing that I discovered, like when I was learning derivative, and it really helps you to, solve all the derivative questions. Like you'll be able to differentiate any function when you have these two groups with you. So first I'll talk about general rule. Then as we are going on, you see that I'll be adding some to either general rule or rules for differentiating individual function. Let's start. So this is the general rule. So general rule is a formula, like, okay, this is how it's supposed to be. So this is the formula, then I'm done. So the first one is the constant multiple rule. So how am I going to do this if I want to differentiate a function like this? So differentiating this is kind of like, now I need to find f prime of f of x. We are differentiating. So a function like this is constant multiple rule. So what we are doing is we want to differentiate c times gen of x. So that's basically what we want to do. And this guy here is a constant, so the constant comes out, and then we just differentiate the gen of x, right? We just differentiate the gen of x, and this is going to give us c times gen prime of x. So it's basically having something like f prime of x is equal to, you maintain the constant. Anytime you see that the constant is multiplying the function, just maintain the constant and then just differentiate the function associated to it. So one thing that you need to know is the constant can be just something multiplying or dividing. If we have another one that goes like f of x is equal to 1 over c, or let's say gen of x this, if it is of this form, the same thing, f prime of x, just factor the 1 over c out and differentiate the gen of x. So that is the constant multiple rule. Remember, factor the constant multiplying the function and just differentiate the function. Let's talk about the sum rule. Sum rule, it's kind of very simple. So f prime of x is basically just differentiate individual function. So this is going to be gen prime of x plus h prime of x. This is just the sum rule. Differentiate individual function, and you just take it along, and then you are done. So that is basically how it's supposed to be. But if I want to write it more generally, then I'm going to write something like d over dx, then gen of x plus h of x, and then this is going to be like differentiating gen of x plus, now you differentiate h of x, and this is going to give us gen prime of x plus h prime of x, which is kind of very simple to do that. So remember, everything that we are doing here is what I call the general rule, which is the formulas. So I need to just have this formula that whenever I'm differentiating a function, which is the constant multiple rule, just factor this one out and differentiating this. But the one that I was talking about, what is this one, the rule for differentiating individual function, is now the rule that it will help us to know that, okay, how am I going to differentiate this gen of x? That's what I call it, the rules for differentiating individual functions. Let's look at the difference. So the difference, this is going to be f prime of x is equal to gen prime of x minus h prime of x. Don't forget, we have trial questions also here. So we are going to practice with the rules that we are learning here. And I have a trial question that I'm going to also give it out at the end of the video for you to practice. Good. So now we've learned the constant multiple rule, sum and difference rule. Let's talk about product rule. I love product rule a lot. So product rule, anytime you have two functions, I like using a and b. This is how we do it. So I pick my A, I pick my B. So this is my A, this is my B. Then when I finish, now I need to differentiate A and I need to also differentiate B. Then when I finish, I multiply this to this and then also this to this. And this is going to give me the product rule. So this is going to be AB prime plus A prime and B. So I differentiate, I maintain A, I differentiate B, plus now I differentiate the A and maintain the B. So that is the product rule that we just need to remember anytime we have two functions that are multiplying each other. Let's talk about the quotient rule too as well. Quotient rule, I have U, I have my vin, so I need to look for U prime, I need to look for vin prime. When I'm done looking for U and vin and U prime and vin prime, then my F prime is very simple. Here the order is important. Here with product rule, I can write this one too as A prime B plus AB prime. Is also correct. It does not matter the order, whether this one is coming first or this one is coming first. But here the order is very important. Here we maintain vin first and then we differentiate U minus, now we maintain U and differentiate vin, then we divide it by vin squared. So this, you cannot bring this one first followed by this because of the negative here, right? So always vin, so always the red one first, right? And then the blue one second, right? So if you are arranging it in this form, that's how it's supposed to be. So U vin, U prime, vin prime. Then you need to go with vin and U prime followed by U and vin prime. So this is the quotient rule. So as I said, this is kind of formulas. So you see that this is a formula that I need to learn. This is also a formula, right? Same thing to this is also a formula. This is also a formula, and then this one too is a what? A formula. So now we've learned the general rule which talks about the formulas. Now let's learn two rules for differentiating individual functions. And then now we take example. So two rules that we are going to learn here is the constant rule. So constant rule, I call it a rule for differentiating individual functions because it tells us that anytime I have a function which is a constant and I'm differentiating it, I'm going to get 0. So when I differentiate C, C is a constant. So when I differentiate it, I get 0. So this is a rule that differentiates individual function. What's the function here? Constant. And when I differentiate a constant, I get what? 0. Good. Let's look at another rule, which is part of, so you can get a book and be writing the rules, group them the way I've done it, and it's going to help you a lot. Now, let's talk about power rule. This is also a rule that we use to differentiate individual function. We will take example after this and you will see what I'm trying to talk about. So power rule says that for me to differentiate this function where n is constant and x is the function here, then it says that drop the n, so drop this n here, multiply it by the function, so I put the n down and multiply it by the whole function, but I'm going to subtract 1 from it. This is very, very important. Drop the function, subtract 1 from the function. That's all. So this is the power rule, and this is the constant rule for differentiating individual function. And let's take example and work with that. Now, because I'm teaching you how to do derivative, I'll take my time. So stay here with me. Now, the first thing that I need to ask myself is, this, we can see that this is the rule, right? This is the general rule. Which rule is that? This is the constant multiple rule, which says that if I want to differentiate this, f this, I need to maintain the 10 now and differentiate what is here. So now I'm come to differentiate x squared. Now that I've realized that this is the constant multiple rule and I need to maintain my constant, I've done that. So what am I going to do? Now I'm come to differentiate what is inside the bracket. Don't worry, I'll be doing it direct very soon. So I maintain this and then I just did this. Doing this is the first rule that we learned here, constant multiple rule. Now differentiating this is the rule that we learned. We need to use the power rule because we have x to the power n and here our n is squared. So using the power rule, this one is going to give us 10. Then this one will be 2x 2 minus 1 from the power rule that we learned. And this is going to give us 20x. So it means that doing it directly, you will see that when I differentiate f of x is equal to, when I differentiate the function direct from the top, since I know it, I'm going to multiply the 2 by the 10, and then I'm going to have 20x. So that is how it is. So I'm taking my time to go through because I want you to understand it. And then afterwards, you can just ignore the whole process of this and just write it straight away, right? So you see, grouping them is very important. Now looking at this here, this here is like combination of the constant multiple rule, we have the difference rule, and we have the sum rule. But how are we going to do this? Let's see what we can do from here. First, I need to simplify. Some of the functions you need to simplify before you can differentiate. So this function is the same as 3x to the power 4 minus, this can be written as x to the power 1 over 3 because cubic root of x is the same as x to the power 1 over 3 plus this one can be written as x to the power minus 2. I'm doing this so that this two function here will be like the power rule, like n x to the power n, so that here my n will be 1/3 and here my n will be -2, right? Now that I was able to do it in this form, now I can start the differentiation. So which rule am I going to use? Now that I've identified the general rule, now I need to think about which type of rule that I'm going to use to differentiate the individual function. So individual function here, individual function here, individual function here, I need to use the power rule. So let's do that. This is going to give us 12x, or let me just write it small since we are now learning. So 4x 4 minus 1. So I maintain my 3, I drop my 4x to the power 4 minus 1. Now minus, drop the 1 over 3, and then this is going to give us 1 over 3 minus 1. Then plus, or drop the minus 2, so it's going to be minus 2 x to the power minus 2 minus 1. See, that's very nice there. Then this is going to give us 12x to the power 3 minus 1 over 3x. So 1 over 3 minus 1 is minus 2 over 3 minus 2x to the power minus 3. So this is the derivative. So you see that now when you become very good, you can try to skip this step, right? Simplify this and you can just use your eye and then write this. But it's always good for you to be doing this if you are now new to finding derivative. But if you are very good, then you can use your own way of doing the derivatives, right? Let's go. So you see that all the example that we are doing, since we've talked about only two methods, constant rule and power rule, you will see that everything that I'm doing here, I'm using these two rules for differentiating individual function. The rest, I'm combining the general rule, which is the formulas. Now, which general rule am I going to use? So the general rule that I'm going to use here is the product rule. So now I've identified the general rule. So since that I've identified the general rule, what's the general rule? I pick my A and B because this is the product rule. So I'm assuming that this term here is A and this term here is B. So let me write it. A is equal to x squared plus x minus 1 and B is equal to 2x plus 1. Now using this, we need A prime as we learn from the general rule and B prime. Now differentiating this and differentiating this, we need the rule for differentiating individual function. So which one are we going to use for this? This is the power rule, this is the power rule, and we need to use the constant rule for this. So using the power rule, I'll just do it straight. So differentiating x squared is going to give us 2x. I hope you know how to do that. And then when I differentiate x, I'm going to get 1 because it's x to the power 1. So when we are using the power rule, 1 will drop down, then x 1 minus 1. So 1 times 0, x to the power 0 is 1, and this is 1. So know that when I differentiate x with respect to x, I'll get 0. Then when I differentiate minus 1, since it's a constant, when I use the constant rule, I differentiate 1 and I get 0. Let's come here. When I differentiate 2x, this is the constant multiple. So I maintain my 2 and differentiate x. I'm going to get 1. So this is going to give me 2 times 1, which is 2. I differentiate the 4, I get 0. So you see the way I'm combining the general formula and then the formula for finding or the rules for finding individual function. When you become very good, you cannot think about them. You can just be doing them straight away. Now let's look at this. So now f prime of x is equal to, we know the product rule. We need to multiply one of this to this and then this side to that. It's a product rule. The order is not important. It's the quotient rule that the order is important. But here, you cannot multiply this one to this. You should be going diagonal like this or this and that. So let's do that. So if I choose a prime and b first, I'm going to multiply this one to this. So I'm going to have 2x plus 1 times 2x plus 4 plus multiply this to that. I'm going to have 2x squared plus x minus 1. So I can choose to leave my answer in this form. So if it is not for me to simplify, then I just leave it in this form. But if it's for you to simplify, then you go through and do the simplification. Now let's look at D. D, we are going to use the quotient rule because we have the fraction, right? So this, I'll pick the u on the top and vin at the down. So indicating this means that the u is here and vin is also here. So the first thing I said was quotient rule. So I was able to remember one of my general rule, which is the quotient rule. So that one is just a formula that I need. But now, since I need u prime and vin prime, I need to think about which rule am I going to use to differentiate the individual function. This is the power rule. So this is going to give us, I hope we can all do it now. This is going to give us 6x, right? And then this is going to give us 1 because differentiating x will give us 1. Use the constant rule and we get 0. So we get something like this. The question is, what is the quotient formula? Vin u prime minus u vin prime divided by vin squared. So as soon as I know these formulas, now everything is set. I just need to do direct substitution. So vin is here, u prime is also here. So multiply this by that. So I'm going to have 6x x plus 1 minus u and vin prime, u times vin prime, I'm going to have 3x squared times 1 divided by vin squared, what is x plus 1 squared. I think this one we can simplify the top small. So we are going to have 6x squared plus 6x minus x squared, then x plus 1. And then the top, when I do the subtraction, I'm going to have something like 3x squared plus 6x divided by x plus 1 all squared. So this is also the quotient rule. So you see the way we were able to, putting things together, like the way we are solving things and then using them. Good. So let's do, I think, last two or one question and let's go. So this one I need to simplify. So as I said, some of the functions you need to simplify before you can differentiate. So I need to simplify this one so that I can now start the differentiation. So this is the same as x to the power minus 3 minus 5. So what is gen prime of x? Use the power rule. This is going to be 4. This is going to be 8x, right? Because 2 will multiply this, subtract 1, and then we have this. and then this is going to give us minus 3x to the power minus 4, right? Because negative 3 drops down, you subtract minus 1, and then you have this. And then using the constant rule, when I differentiate this, it gets to 0. If you want to simplify this, this will be 8x minus 3 divided by x to the power 4. That's what you're going to get. I think this is the last question, and then I'll give you a trial question to try and leave your answer in the comment section. Let's simplify this. This is the same as 1 divided by x to the power 1 over 2 plus x to the power 5 minus x this. Now this I need to simplify again. This is the same as x to the power minus 1 over 2 plus x to the power 5 minus x to the power minus 2 before I differentiate. So as I'm saying, some of the functions you need to simplify them before you what differentiating. So now let's differentiate this using the power rule. Minus 1 over 2 drops down, then you subtract minus 1 from it, plus 5 drops down, subtract 1, then minus 2 drops down, and then subtract 1. Good. So this is going to give us minus 1 over 2 minus half minus this is going to give us x to the power minus 3 on 2 plus 5x to the power 4 plus 2x to the power minus 3. So this will be your final results. If you want to simplify it, you can just go ahead and simplify this. So before I give you the question, I just want to summarize this. So we saw that now the general rule formulas is this. So the general rule is like kind of, we are talking about formulas, something that you need to know. So I know that quotient rule, f prime of x is equal to vn u prime minus u vn prime divided by vn squared. Now somebody can use f of x and g of x is also the same thing. I know that the product rule f prime of x is kind of a b prime plus, let's say, a prime b, right? That's my formula. This one, if I'm using other function, I know that f of x is equal to g prime f of x plus or minus, because I'm dealing with the sum and then the difference rule, and then let's say h prime of x. And then the constant multiple rule is kind of f prime is equal to c g prime of x. So these are like kind of formulas that I need to learn. So knowing this, it's the best. Then this rules here, that's the constant function and the power rule, help us to differentiate the individual function g prime, h prime, a prime, b prime, and vn prime, and then the u prime. So these are the ones that it's help us to differentiate. And you see that as we are moving along with this video, I'll be adding some to the general rule, I'll be adding some to the rules for differentiating individual functions. So we saw that f prime of x, if it's a constant, it should be getting 0. And then if the function is a power rule, f prime of x should be n minus 1. So please keep this in mind. Have some book and write them down, because as we are going through the videos, you'll be using them a lot. Now, this is a trial question for you to try and leave your answer in the comment section. I appreciate all those that they solve, they take time to solve and leave their answer in the comment section. You guys are doing very well. I appreciate that. So look at this one and apply the rules, and think of, okay, this is what I'm doing. I need to simplify this, and then you solve it very nicely and you leave your answer in the comment section. So in the next video, we are going to pick another set of rules, right? And then also talk about it. So see you in the next video.